Today we will talk more about line segments. When we name line segments, remember that we name the segments with a bar on the top to indicate that it's a segment, and with two letters that represent the endpoints. So here you can see we can name a segment with endpoints A and B in two different ways. And that's different from a line because a line has the arrows and the segment does not. We can measure a line segment's length. Most people would grab a ruler and measure that line segment, see how long it is, because it does not go on forever. When we talk about the measure of line segments, we use just the letters of the endpoints. So when you see AB without this little bar here, that means we're talking about the measure or how long it is. Now, one of the key concepts that we use when we talk about line segments is the idea that certain points can be located between one another. So in this case, if you look at the picture, we have point P, point M, point Q. Point M is between points P and Q. If and only if P, Q, and M are collinear, meaning they lie on the same line, and the plus the Q equals the length of PQ. So what we like saying here is a part plus a part equals the whole segment. So here you have a part, PM. Here you have a part, MQ. And here you have the whole, PQ. And that's how we designate segment addition. Here again, we state that part plus part equals a whole. Problem 1A is asking us for JL. That means the length of JL. How long is it? Well, JL has two parts. It has JK, it has KL as parts, and then that would equal the whole segment, JL. So we take the 8.4 part, the 3.9 part, we add them together, and we get 12.3. Looking at example B, we want to know the length of AB. And point B is between points A and C. You can see B here is in between the two endpoints. Now here we have a part and we have a whole and we're missing another part. The part AB is what we want. So we have to set up our part plus part equals whole again. We say that AB, that part, plus BC, that part, equals the whole, AC. And when we substitute, we get X for AB. We could really call that any variable, but Desmos uses X as a standard way of entering a variable. Plus the other part, 5.8, equals 13.2. And when we solve for that, we're going to end up subtracting, and that'll be 7.4. Now let's take a break. You try these, and we'll come back. Remember, you have to set up part plus part equals whole for each statement. So here, for the first problem, we want CD. That's the whole. So we'll say part plus part equals whole. So the 1.1 plus the 2.7 equals the whole CD. And if we add 1.1 and 2.7, we will get CD equals 3.8. Here, RS is a missing part. We have another part, and we have a whole. So part plus part equals whole. So one of our parts is missing. One of our parts is 1.6. Our whole is 4. We can put this into the Desmos calculator, or we can simply subtract. So we will get x equals 2.4. Now, when we solve for a variable, we have a little bit more involved in the equation, but it's no different with the part plus part equals whole. So let's take a look at an example. It says find the value of a if y is between x and z, and it gives us a lot more information. But I'm thinking in my head, where is my picture? So let's draw that picture. Let's say x, let's say z, and y is somewhere in between. So now we can label xy, that's a part. We can label yz, that's a part. And we can label xz, that's a whole. And we can set up our equation. So one of the parts plus another part equals our whole. And when we solve that, we can put that in the Desmos calculator with the x's to solve it if you prefer. I'm going to solve it by hand. And x equals 9. So we've solved for the variable. Now how can we check it? Well, we can substitute 9 everywhere we see the variable. So xy is 3 times 9. We already know yz. So 3 times 9 is 27. So 27 plus 14 should equal 41. So if we substitute in here 5 times a, or 9, is 45 minus 4, which is 41. And it looks like we check. Now you try one. We'll pause the video while you take a moment. Make sure you draw a picture. I wouldn't have written this up at the top if it weren't important. I'm going to draw a picture. It says B is between C and D. CB is 2x, BD is 4x, and wait a minute, BD is 12? That really doesn't make a lot of sense. So I think what has happened here is that this, and I'm going to correct this, this should be CD. And my apologies on that. So we'll do part plus part equals whole. 2x plus 4x equals 12. And x is 2. Now we can figure out what BC is. We can substitute in 2 times x, where x is 2, is 4. So BC equals 4. This problem actually has two different parts to it that they wanted us to figure out. Try another one. Again, please draw a picture, and remember that B is between C and D. We'll pause the video here while you try it out. So what we'll do is we'll draw a segment with a C and a D and a B. CB is 4x minus 9. BD is 3x plus 5. And CD is 17. So remember, part plus part equals whole. So one part is 4x minus 9. The other part is 3x plus 5. And the whole is 17. Now you could put it into the Desmos calculator. And we'll get x equals 3. But they also want to know BC. So here's the piece we need. BC is the same thing as CB. 4x, or 4 times 3, minus 9 is 12 minus 9, which is 3. And we are done.